All right, let's talk about adding waves. Waves, you remember, we usually represent them as sine waves like this. So this would be one wave. What happens when this sine wave encounters another sine wave? And we're going to pretend like I'm a good drawer. I know, kind of funny. And what if we have a wave that is identical? Again, we're going to pretend like I'm a good drawer. What does the net wave look like? What kind of interference pattern happens? Now we're going to pretend like this is our equilibrium line. Again, we're going to pretend like I'm a good drawer. At every point, these waves add. So at the nodes where it crosses the equilibrium line, 0 plus 0 is 0. This is my equilibrium line. Now at the maxes, okay, these are supposed to be the same wave. So if this is up at amplitude A, the final wave will be up an amplitude of 2A because it's got two of them. All right, same here, and same down here. So if I add these two waves, I get this really big wavefront. Remember, Fourier analysis can break apart waves into their constituent waves. Now, this is if I have two waves that are completely in phase and have the same amplitude. What if I have two waves that are out of phase? Same amplitude. All right, so we have that wave. And now the blue wave. Okay, goodness gracious, y'all have to do with my drawings. I'm sorry. Okay, we're going to pretend like that really is a good wave. What does the net wave look like here? Well, always go and add your zeros. Okay, we're going to pretend like that's at the 0 there. Okay, just kidding. Y'all appreciate my drawing because you know it means I'm not going to be real critical of yours. Okay, if this is plus A, this is minus A. So the resultant wave here is just a flat line. This is destructive interference. INT, goodness. And this is constructive interference. Now, most waves really aren't either completely constructive interference or destructive interference. Destructive interference, you remember, is more the noise canceling, headphones, that sort of thing. Constructive interference is when you have, you reach resonance and, bridges fall down or crystal breaks. For the most part, there tends to be two waves that are just off somehow. They have different heights, they have different frequencies, and you simply add them at every point. This gets very complicated. This is partial destructive interference. Now, suppose I have a wave, amplitude 0.3 meters. So it looks like this. We're going to just do one. Here's my equinodal line, my equilibrium line. So this is 0.3 meters from equilibrium to the crest. And of course, it's 0.3 meters from equilibrium down to the trough. Okay, and it interferes with a second wave of amplitude 0.2 meters. So let me do this one, 0.2. And I'm going to draw them in phase because it might be easier. So this is 0.2 meters and this is 0.2 meters. What's the largest resultant displacement that you can have? Well, of course, it's going to be when these two add. So 0.2 plus 0.3 is 0.50 meters.